Hello class, welcome to SciChem. Here we are another session for lecture number 10. In the previous class we have discussed about how to write rate law expression by using rate determining step. We have already studied two types of cases: if RDS is given, if RDS is not given. For the reaction mechanism, if a rate determining step is not given, we have to use steady state approximation, and we have already discussed what is steady state approximation. In this class I have given some problem and I am going to solve that problem, that is so this is the equation. 2a gives rise to 3b gives rise to 4c, and for that it's k1, k2, k3, and I have to calculate the value of dA by dt plus dB by dt. Before solving this kind of problem, I have to write the mechanism of the reaction, and the mechanism of reaction is as follows, that is 1, 2a gives rise to b gives rise to c. Two a gives rise to 3b, 3b gives rise to 2a, and again 3b gives rise to 2a gives rise to his rate constant, and this is k3. So for this type of reaction I can write the rate is equal to k1. For this reaction I can write rate is equal to k2 0 power 2. For this reaction I can again for this reaction I can write rate is equal to for this reaction rate is 1 by equal to by so now what is the value of as A is the reactant, and the reactant A involves in first reaction and reaction. So since both the reactions involves, so net change in minus dA by dt, I can write here for this minus dA by dt here minus the dA by dt. So here rate is equal to k1 as to a raw power 2, and rate is equal to half into minus dA by dt. I have to calculate the value of minus dA by dt from this two rate. So I can write here minus dA by dt is equal to 2 times k1 0 power 2 minus here dA by dt is in terms of plus, but I have to calculate minus, so minus 2k2 dB by, for dB by dt, P is involved in all three reactions, So I have to calculate net change in formation of B. Here B is in plus, but here is in minus, so I can write here 3 times K1 0 power 2 2 3K3 B 0 power 3 8 by I have to calculate plus Cc by T, and C is involved in the third reaction only, so I can simply write 4K3. This is all about steady state approximation. And now we are going to deal with some special cases of first order reaction. Case 1, parallel or side reaction. We have already discussed in organic chemistry. Let us consider chlorobenzene on chlorination results parachlorobenzene or chloro means this type of reactions are called parallel or side reaction. And from this reaction we can orthochloro and parachloro, we can calculate what is major product, what is minor product, what is major product. The percentage depends upon the major or minor. More is the percentage of a product, that will be major product, to lesser is the percentage, that will be minor product. And how to know what is major and what is minor? We have to read or discuss about parallel reaction. Is important. So in case of let's consider a simple reaction. A gives rise to B, and for a parallel reaction here, when T is equal to 0, initial is, but for a parallel or side reaction, this is for simple reaction, but for parallel and side reaction I have A gives rise to B and C. So when time t is equal to 0, it have constant A. Time t when time t is equal to 0, it concentration for B and C are B. But after time t is equal to t, if x amount of A will be dissociated, y amount of B will be, amount of C will be formed. I can write if the stoichiometric coefficient 1:1. And for this parallel reaction, there are some things we have to calculate: a effective order, effective half time, effective rate. We are going to deal with question number 1. So for the above reaction, I can write minus dA by dt is equal to A1A plus A2A. How am I writing this? Because in the previous class or in this class we have already discussed how to write this type of equation. A gives rise to B, A gives rise to A1, rate is A to A, where rate equal to plus dA by dt is equal to minus A. So since A is involved in these two reactions, net change in concentration minus dA by dt is equal to K1A plus K2A. So minus dA by dt equal to 1 plus 2 and minus dA by dt is equal to A effective, just like first order reaction. First order. So here we have solved one question. K effective is equal to effective rate plus K. And if we have to calculate order, minus dA by dt is equal to K effective into A power 1. So here also we have calculated equal to if order. So we have to calculate effective half-life. Since it is the first order type reaction, I have K effective is equal to K1 plus, and you can write P half effective is equal to 0.693 by K effective, and it will be equal to 0.693 in terms of K effective K1 plus. By solving K1 K2, 0.693 by K1 half value 0.693 by P half plus in terms of K2 0.693 P half. By solving this, you can have P half to 0.693 0. This remaining 1 by T 1 half up to half, is effective half-life time. And next part is effective activation energy. Then how to calculate effective activation energy? We have K effective is equal to K1 plus 2. For this K effective, I can write A effective 0 power minus EA if RT in terms of K1, right? 1 minus EA RT 2 or EA 2 3. Then differentiate equation T. I have differentiating, since A effective is constant, right here A effective 2 multiplied by if because differentiation of this amount differentiation will give as a constant, and this is the differentiation A effective by RT. Similarly, two into A2 by R. So this is our K effective, is our K1, this is our, and cancelling RT square, we have A effective to EA is A1 K2. This I can easily calculate. Effective activation energy edge A1 by, so all the 4 questions are being solved. So what we have calculated, effective order is came to be 1, effective half-life, effective rate. So now we are going to calculate the change in concentration of A, B and C. Change in concentration of A, B and so concentration of A minus A by T equal to, and we have already calculated change in concentration A after T for faster reaction have A power in case of right equal to the power parallel reaction I have equal to not in K1 plus to T. Now for calculation of concentration of B plus dB by dt equal to how concentration of B dB, so plus dB by dt is equal to K1 into A C B by variable separation dt take B a1 a naught into e to the power minus B by solving this I can write B limit a1 a naught is the difference minus a1 plus a2 into e to the power a2 t. For 0 to t, for 0 to t, if you put t, then again the expression is same, e to the power minus k1 plus k2 into t. Yeah, if I have to put 0 in terms of t, then there will be e to the power 0, that is e to the power minus 0, that will be minus 1. So minus 1, and by solving, by multiplying this minus in both side, can write have b is equal to k1 a naught divided by k1 plus k2 into 1 minus or k1 plus 2. So this is concentration of C. For concentration of C, dc by dt equal to 2 into k, by dt is equal to k2 into. And for this we can easily write C is equal to, since dc by dt is equal to k2 into a, and a have concentration, and by solving we can get the same expression, but instead of k1 I have to write here C is equal to k2 a naught plus k2 1 minus e to the power k1 concentration of C. So this is concentration of A, B and C. Another question is there, calculate ratio of concentration of B and C as well as percentage of B and C in the product. What is the ratio of concentration of B and C? So this is concentration of B, there A, small a and small b, the equation for concentration of B and C. So what is the ratio of these two? Concentration of B divided by, since the question is asking what is the ratio of concentration of B and C, so B by C equal to, same expression will be cancel out each other and the remaining will be A1. But here asking another question, percentage of B, the, for percentage of B and simply write percentage of B is equal to B divided by B plus C into 100, that is total concentration. It is concentration of B divided by total concentration into 100. So in order to solve this, add 1 on by B by C is 1 plus B by C is equal to 1 plus K1 by B by B by B plus B by C is equal to K1 by K2, right? Intersection of C by B, add 1 on both sides by C by B plus C plus K2 by. So in terms of B plus C by B, input B by B is a percent. B by B plus C, B plus C by B is equal to K1 plus K2 by K1, right? K1 by or 1, I can T half 1 here 0.69 by T half effect. So by solving this, I T half by similarly of. So this is all about the special cases of first order reaction is parallel or side reaction. We have already solved of question. Calculate ratio B and T and A. Thank you.